Good afternoon, everyone. How's it going, Isaiah? So we're going to start off with that Digital Agenda 327 and 330, the one that I just assigned to you guys. Let's wait for a few more people to hop on here. Let's give it a few minutes. Indy, I think how's it going, Jorge? The agenda should be 327 and 30, just because school's on Monday. Let's go, 4 students. Technically, we don't start for another, let's see, 2 minutes. So we're going to wait 2 more minutes. Hope everyone's having a good Fridays. Looking forward to the weekend. Anybody have any plans for the weekend? Let's see. So I hope everyone here is looking at the digital agenda for 327. Can everyone see that fine? So based off of the last lesson that we did, we learned about the product rule, we learned about the power rule, we learned about the quotient rule. So in this problem on the first do now, on the digital agenda, they want you to simplify the expression. And they tell you that you have, it's 3 to the second power times 5 to the third power times 8 in the numerator, and 3 to the first power times 5 to the third power times 8 in the denominator. So we can simplify that by canceling terms out, and I want to show you guys what it looks like the long way. So 3 squared, remember, is just 3 times 3. 5 cubed, 5 to the third power is 5 times 5 times 5. And 8 just multiplied once. So let's move on to the denominator. It'll be 3 times 5 times 5 times 5 times 8. Geraldine, that's exactly what it would be, but instead of multiplying them out, we can actually just cross cancel terms. So I hope everyone here is familiar with the term cross cancel when it comes to fractions, because what I'm going to do now is simplify this fraction by crossing like terms out in the numerator and the denominator. So watch what I mean. But yeah, 3 times 3 is 9. 5 times 5 times 5 is 125, and then times 8. All right, so notice what I just did. In blue, I crossed out terms in the numerator and the denominator. The only reason why we can do that is because there are like terms in the numerator and the denominator. What I mean by that is that 3 and 3 can cancel, right? We can put x's on those. Then we look at 3 again in the numerator. There's not another 3 to cancel in the denominator. But if we look at the 5s, there's 5 times 5 times 5, and also 5 times 5 times 5 in the denominator. We can cancel those out. They all match up. And same for the 8s. They match up. So all we're left with is 3. Does everyone see that? Happy Friday, Mr. Lopez. Happy to help. I think Miss Trong is having some issues. Hopefully she can get on here. Does everyone see how we got 3 for the first problem? A on the do now. So we expanded the terms, and after we expanded them, we crossed out all of the like terms in the numerator and the denominator. And all we were left with is 3. Let's look at B. So in B, they give us the problem 3x to the 4th. India, what you want to hold up and look at number A again really quick? What didn't you understand about that? Should I start from the beginning? For B, yeah, Jorge, good. It's 3 times 3 times 3 times 3. But don't forget about your x as well. Let's look at A one more time, because that one definitely was confusing. So what I do for this type of problem, I can expand out the terms, meaning I can do 3 times 3 times 5 times 5 times 5 times 8 in my numerator. Let me write that out. Okay, in blue, I'm going to cross off the number of times I see 3 in the numerator and the denominator in a blue slash. Meaning when I look at the expanded form, I see I have 3 times 3 in the numerator and 3 in the denominator. So since I have it in the numerator one time and the denominator one time, I cross them off there in blue checks. When I look at the next term, 3, there is not another 3 in the denominator for me to cross out, so I have to leave that by itself. That's the only like term that's left. Let's look at the 5s. When we look at 5, we have 5 times 5 times 5 in the numerator, and we also have 5 times 5 times 5 in the denominator. So here they exactly match up, and that's why the terms cancel. Does everyone see that? And for our 8s, we only see them once, so we cross them off as well. And then all we're left with is that singular 3. Good. I like, if you see what Mr. Lopez commented in the chat, what we're really doing there is when we see the same number divided by itself, we can just assume that's 1. Right? So 3 times 3 divided by 3, well, if we look in the numerator and denominator, these are the same. So we can just call those two 1. Now you have 1 times 3. And if you look at the 5s, they all match up. Be times 1 times 1 times 1, right? And then if you look at the 8s, you have times 1 one more time. So all you're left with is basically 3 times 1, 4 times. So that's why you get 3. Hope that clears it up. Good. Let's look at B. So Jorge, I liked how you said, isn't that just 3 times 3 times 3 times 3, 4 times? It is, but I don't want you to forget your variable. Because remember, everything that's inside the parentheses is raised to the 4th power. So we have 3 times x all raised to the 4th power. That means we're going to do 3 to the 4th power times 3, or times x to the 4th power, excuse me. So we'll do 3 to the 4th power, that is 3 times 3 is 9, times 3 is 27, times 3 is 81, times x to the 4th. And your final answer is 81 x to the 4th. Does everyone see how I did that? Right? We have 3x inside the parentheses, and everything inside the parentheses is raised to the fourth power. So we have to do both terms. 3 to the fourth is 3 times 3, which is 9. Times 3 is 27, and times 3 is 81. X to the fourth remains x to the fourth, so your final answer is 81x to the fourth. Can I move on to the next one? Can I move on to C? All right, question C. So this one seems a little bit tricky, but it utilizes the same knowledge we used in the first problem. So C, they give us 3 to the third power times 3 to the fifth power times 1/3 to the second power. Can anyone tell me what 3 to the third power times 3 to the fifth power is? Before we look at the fraction, what's 3 to the third power times 3 to the fifth power? Type it in the chat, please. You can just write the exponent. When we are multiplying our exponents that have the same bases, remember, the product rule tells us that we can just add our exponents. So 3 to the third power times 3 to the fifth power. Can anyone tell me what that is? Exactly, 3 to the eighth. So we combine that first and say this is 3 to the eighth power times 1/3 squared. So now we have to look at this fraction, right? We have 1/3 inside the parentheses raised to the second power. Well, remember what we said about the parentheses. Everything inside the parentheses receives that exponent. So this is the same thing as 3 to the eighth times 1 squared over 3 squared. Like this. You have 3 to the eighth times 1 squared over 3 squared. All right, that's how we simplify that. And then we know 1 squared is 1. So we can just say this is 3 to the eighth times 1 all over 3 squared. Now, we can take this a step further. If we have 3 to the eighth power times 1 over 3 squared, we know 3 to the eighth power can be written as a fraction over 1, right? So if we multiply these fractions now, you would get 3 to the eighth over 3 squared. Now, what's 3 to the eighth over 3 squared? What does that simplify down to? Can anyone tell me what 3 to the eighth divided by 3 to the second power is? Andre, we'll go back and do a full question review. I know it seems confusing, but exactly, it's 3 to the 6th power. We get 3 to the 6th because we use the quotient rule. And you guys learned that rule in your last digital agenda that was due yesterday. 3 to the 6th. Okay, let's review how we got here. Well, we had 3 to the 5th power times 3 to the 3rd power. All of that times 1/3 to the 2nd power. So first we combined the first two terms because we noticed we can just use the product rule. 3 to the 5th times 3 to the 3rd is 3 to the 8th. Okay, after that, when we get 3 to the 8th times 1/3 squared, we can rewrite that as 1/3 squared, like this, with the exponent in the denominator. Okay? After that, we can just simplify and realize that we have 3 to the 8th in the numerator and 3 to the 2nd power in the denominator. And then we can use the quotient rule to get 3 to the 6th. Let me know if you guys understand that or if we have to do another one similar to this. This is similar to the classwork we did, Jennifer. Does everyone understand? Let's move on. Let's move on to the next problem. Well, let's see if we can do a similar problem. That'll help. D goes hand in hand with this type of problem. Let's look at D. Okay, in this problem, we have 7 to the 4th power times 9 to the 2nd power. And then we have 9 to the 3rd power over 7 to the 2nd power. So how do you guys think we can simplify that? Can we use the quotient rule? Can we expand out the numerator and can we expand the denominator? I don't need any bread. I'm all right here. What is, let's look at it like this. There you go, Jorge. 7 times 7 times 7 times 7 times 9 times 9. The only form of payment I'll accept is your guys' understanding of this material. Okay, so yeah, on the bottom, good, Jorge, you have 9 times 9 times 9 times 7 times 7. Can anyone solve this problem using the canceling method, or can anyone tell me what I could do using the quotient rule? There's two ways we can attack this problem. You guys, which ones can I cancel out? How many 7s can I cross out? It's 49 over 9. Cross out all the 7s and all the 9s. Okay, but there's only a certain amount that I can cross out. How many can I cross out for the 7s? India, that's exactly right. You got the answer is 49 over 9, but leave 1 7 and 1 9. Jorge, we're gonna leave 2 7s and 1 9. Ready? Exactly. So we have 2 7s on the top and 1 9 on the bottom. And that's how we get our answer, 49 over 9. So that's method 1. Okay? I want you guys to get familiar with this second method that I'm about to go over. So we're going to get the same answer as 49 over 9, but watch how we can do it this way. This is using the quotient rule. Okay. Let me just make sure I have this down correctly. Good. So if we look at the exponents in the numerator and the exponents in the denominator, let's look at our first term, 7. So our numerator for the base of 7 has an exponent of 4. In the denominator, my base of 7 has an exponent of 2. So can anyone tell me what I would get if I use the quotient rule in my numerator? Someone tell me, what's 7 to the 4th divided by 7 to the 2nd power? What is 7 to the 4th over 7 to the 2nd? India, how did you get 7 to the 2nd power? That's exactly correct. Can you enlighten the chat for us, or do you want me to explain it? Here, I'll do it. Don't worry. So, you guys, when we use the quotient rule, and you have 7 to the 4th divided by 7 to the 2nd, remember, we subtract our exponents. Quotient rule means we subtract our exponents when they have the same base. So 7 to the 4th over 7 to the second is the same thing as 7 to the 4 minus 2, which is 7 squared. See that? And 7 squared is 49. That's how we get our numerator of 49. We can use the quotient rule. Let's look at our terms for 9. So if you have 9 squared over 9 to the third power, like that, can anyone tell me what I would get when I do 9 squared over 9 to the third? Is 9 in my excuse me. Can't even talk. Is 9 in the numerator or the denominator? Because you're right, it's just 9, but you have to be more specific than that. Not quite, guys. Look, all you do is 9 to the second power minus 9 to the third power, and you get 9 to the negative 1. And what's 9 to the negative 1? It's 1 over 9. Whoa. Oops. Is that it? Let's take a look at that one more time. So we have 9 to the second power over 9 to the third power, right? What you do is you do 9 to the second, because that's the numerator, minus 9 to the third. 2 minus 3 is negative 1. 9 to the negative 1 is the same thing as 1 over 9. Do you guys want to do another one? Let's do this one. Ready? We're gonna do x to the 10th times y squared times z to the 4th all over x to the 5th times y times z to the 3rd. What would I get for x to the 10th over... No, this, India, you guys, this is just a practice problem. This one more. I want to see if you guys get this one. So if you have x to the 10th times y to the 5th times z to the 4th all over x to the 5th times y times z to the 3rd. So you get exactly x to the 5th times y times z. To get this answer, we did x to the 10th over x to the 5th. Well, we know we can use the quotient rule. So this is 10 minus 5, which is 5. So x to the 5th. For the y's, we have y squared over y. So that's 2 minus 1, y to the first power. And then for the z's, we have z to the 4th over z to the 3rd. So 4 minus 3 is 1. And that's why we just get z. Okay, let's look at the... Hi, Miss Strong. Let's take a look at the second problem for the do now. So everyone open up the second do now problem on the digital agenda, please. I'm going to write down the instructions. So it says that 2 of the problems below are correct and 4 of them contain errors. All they want you to do is tell them which problems are correct and which problems are incorrect and why. Once you tell them why, you have to find the correct answer. So let's look at A. Is this a valid answer? They have x to the 3rd times y squared times x to the 4th. They say this equals x to the 7th times y squared. You guys, is this correct? Is this valid? Does this have any errors? Okay. Snyder, we're going to have to... Is this valid? Geraldine, you say no. Jennifer? Well, you guys, this is multiplication. When terms are lined up next to that, there's still multiplication. Oh, you meant yes. Okay, good. Yeah. So we have x to the 3rd times y squared times x to the 4th. Yes, this is valid, right? We can do x to the 3rd times x to the 4th. When we use the product rule, we add the exponents. So 3 plus 4 is 7. And we don't have any other y terms. So the first one is valid. So you can say correct, valid. Put a check mark by it. That's fine by me. Let's look at B. Yeah, it is right. X to the 3rd times x to the 4th is the same thing as x to the 3 plus 4, which is x to the 7th. Don't forget your product rule. Do you need me to rewrite A, India? Sorry. Does anyone else need A? Okay, cool. Let's look at B. So is this valid? They have 2 to the third times 2 to the fourth equals 2 to the 12th. You guys, is this a valid statement? Did they use their rules correctly? Let me know what you think in the chat. Is 2 to the third times 2 to the fourth 2 to the 12th? What do you guys think? So it's not 2 to the negative 1 because we're using the product rule. And the product rule states that when you're multiplying exponents with the same bases, you add their exponents. So 2 to the third times 2 to the fourth is 2 to the... What's 3 plus 4? Yep, 2 to the 7th power, exactly. So is this a valid statement? Jonathan, good to have you here. Exactly, it's 2 to the 7th. So is 2 to the 7th equal to 2 to the 12th? No, it is not. So make sure you let them know why it's incorrect. They multiplied their exponents when they should have added them. Can I move on to C? Alrighty, Jennifer, have a good Friday. Make sure to wash your hands, definitely, especially if you guys are going outside. Don't want anyone getting sick here. Let's look at the third one. C. All right, so this is one of those tough ones again. We have 7 to the second power times 8 to the third power, all divided by 7 to the third power times 8 to the second power. Does this equal 8 over 7? You guys, is this a true statement? True or false? Type it in the chat. 7 to the third over 7 to the second times 8 to the third over 8 to the second. Is this true? What do you guys think? Jeremy, how's it going? What do you think about this problem? True or false? You guys guess. Give me your best guess. What is confusing about that problem? Why is it a true statement, Jeremy? I think you're headed toward the right direction. Okay, good. You guys, why is it right? Let me expand. Let me expand it. Or tell me using the quotient rule. It's kind of hard for you guys to tell me. You can write it out. Or let's just take a look at this. Ready? We're going to do 7 times 7 times 8 times 8 times 8, all divided by. You guys, perfect. It is true. Now let's just look at why. So boom. So India, that's exactly correct. And watch how I do that. I cross off my 7s. I have 2 7s in the numerator. Or 2 7s in the numerator, 3 in the denominator. So that means I can cross off those ones. In the numerator, I have 3, 8. And in the denominator, I have 2. So let me cross off these other 2. And look at what we're left for. Left with 1 8 in the numerator and 1 8 in the denominator. So now that we know, good question, Geraldine. Now that we know they're all wrong, let's explain to them why they're wrong, and we have to give them the correct answers. So we found the 2 correct ones. Let's explain the incorrect ones. There's only 3. So is oh, that one's tricky. That one almost got me. Ready? Let's look at D. Okay, so they give us 3 to the 5th times 3 to the 2nd, and they want us to tell them if this is a true statement or not. So it's 3 to the 5th times 3 to the 2nd, 9 to the 7th. Good. So adding, India, let me just be nitpicky right now. Ready? adding the exponents is correct. What's incorrect is changing the base. So you're right, but I just want you to know that extra step, right? So when you multiply exponents that have the same base, the base doesn't change. The base stays the same. You add the exponents when you multiply. That's correct, but the base doesn't change. So it should just be 3 to the 7th. That's the correct answer. Does everyone understand that? I hope everyone saw the difference between that one. Let's move on to E. Let's see. This one is 6 to the 2nd divided by 6 to the 5th. And they say this equals 6 to the 3rd. Exactly. Ms. Chong, you get it. Now we have 6 to the 2nd power over 6 to the 5th power. Is this a valid statement? Why or why not? So 6 to the 2nd over 6 to the 5th equal to 6 to the 3rd. So isn't it That's exactly right. Is everyone following what's going on in this chat right now? Exactly. So, you guys, they did that perfect. Ready? We use the quotient rule. When we're dividing exponents with the same base, we subtract. So 6 to the 2nd power divided by 6 to the 5th power is the same thing as doing 6 to the 2nd minus 5th. So you subtract your numerator from your denominator. You're looking at the exponents. Right? That's why I'm doing 6 to the 2nd minus 6 to the 5th. That gives us 6 to the negative 3. Negative exponents, we bring them down. This is the same thing as 1 over 6 to the 3rd. Yeah, you were, India, yeah, you were right. Exactly. You guys want to go one step further? 6 to the 3rd is 6 times 6, which is 36. 36 times 6 is 1 over 2, 16. Alrighty, and let's look at E and F. Okay. F tells us that 7 to the third power divided by 7 to the third power equals 0. What do you guys think about this one? Why is this incorrect? Why is 7 to the third power over 7 to the third power not equal to 0? What does it really equal? If you have anything divided by itself, any number, any variable divided by itself is always 1. Exactly. Does everyone see that? That takes us through the do now of the digital agenda. If we look at the language support section, we'll see the rules laid out for us again, just in case we forgot. So, product rule, quotient rule, power rule, negative rule, and the zero rule. They're all there for you. And a deeper look at understanding negative exponents is also there. So I want you guys to take a look at those, take some notes on your own time, understand it, and let's take a look at the classwork 1. So classwork 1 is a video on negative exponents, and then you have to do the practice on negative exponents. After that, you'll scroll down and you'll look at the multiplying and dividing powers video, and then you'll do the practice. And once you're done with that one, you'll do the powers of products and quotients part 2. So all the videos are in the link, and you guys have to do 3 problems from each lesson, so a total of 9 problems. Let's take a look at the exit slip. We're going to go over a preview of the exit slip. So everyone open that up, please, on a separate tab while I get that ready. All right, I hope everyone's looking at the exit slip. If everyone looks at the first question of the exit slip, you'll see something. It says, drag each expression to the correct box and indicate whether the values are equivalent to 3 to the negative 22nd power times 3 to the 5th power. So first, let's just look at what does 3 to the negative 22nd times 3 to the 5th. What does that equal? What is 3 to the negative 22nd power times 3 to the 5th power? Okay, how did you get that, Ms. Strong? What rules did you use? So you said negative 22 plus 5 is negative 17. What rule is that? What rule did you use? Was that the quotient rule or the power rule? Yeah, India, exact. So 3 to the negative 17th power, you guys, the rule we're using is the product rule. Let me write this down. So 3 to the negative 22nd times 3 to the 5th. Let's just use the product rule. Where we add negative 22 plus 5, and that's 3 to the negative 17th. So when we look at the exit slip, there are 1, 2, 3, 4, 5, 6, 7, 8 different options. I'm going to write them down for you guys. Now that we can say that three to the negative 22nd times 3 to the 5th is 3 to the negative 17. The options they give us are equivalent to that value, or they are not equivalent to that value. Let's see which ones are. So you have 3 to the... Okay, sorry, that took a little time to write down. I'm glad you guys like my watch. So you guys, here are the options that they give you below. They want you to drag these into the box. Some of these are equivalent. and some of these are not equivalent. Okay, let's look at this first one right here. So 3 to the negative 22 minus 5. Is that equivalent to Is that equivalent to 3 to the negative 17? I want you guys to start typing yes or no. So, is 3 to the negative 22 minus 5 equivalent to 3 to the negative 17th power? Yes or no? We're looking at this first one right here. No, right? Negative 22 minus 5 is negative 27. So we know that that's not correct. So we'll drag that answer to the non-equivalent box. What about the next one? Exactly, India. Exactly. So what about the next one where they have 1 over 3 to the negative 17th? Is that the same? Is that the same as 3 to the negative 17th? Yes or no? Let me know in the chat. Exactly. So 3 to the 17th power, Miss Strong. So remember, the negative exponents, they want us to rewrite them as fractions using the same base, but we're putting it in the denominator. I hope so. 3 to the negative 1 over 3 to the negative 17th is not the same. Let's take some time on this one. One second, Kasai. 1 second, India. Okay, you guys, when you have negative exponents, you drop them down to the denominator like that. In my red example, you have x to the negative 2 is the same thing as 1 over x squared, right? We're dropping our base on our exponent to the denominator to make the positive. So if we have something that's already in the denominator that's negative, we're just going to bring it to the numerator, like in this one. If you have 1 over 3 to the negative 17th power, that's the same thing as 3 to the 17th power. Kasai, the exit link is in your digital agenda at the bottom of the page. So if you click on that link, it'll take you to the exit slip, and you'll just put in your student ID. Right? That makes sense now. Okay, let's look at this one. They have 1 over 3 to the 17th. So is that the same thing as 3 to the negative 17th power? We kind of just talked about this one. So we know that it is positive in the denominator. But can you rewrite that using a negative exponent? Remember, when you have a negative exponent, you drop your base and your exponent. Because there's only one digital agenda. Exactly. So we're going to put this one into the box that says equivalent, right? 3 to the negative 17th is the same over 1 over 3 to the 17th. So if they give us that option, 1 over 3 to the 17th, we're going to slide it into the equivalent box. Now, what about the one we have 3 to the 5th divided by 3 to the 22nd? Is that the same thing? Well, I'm just going to use the quotient rule. What's 3 to the 5th? Over 3 to the 22nd? Five minus 2 is negative 17. 5 minus 22, sorry, is negative 17. And that's the same. So yeah, that one is also the same. We'll put a check by it also. Let's look at the next one. They have 3 to the 22 divided by 5. So 3 to the 22nd power over 5. Is that equivalent? What do you guys think? One sec. Let me make sure I'm looking at the right. Sorry, I wrote that one down wrong. It was like this. So for this one, if you have Hey, Susanna, you can turn them in on Google Classroom. You can send pictures of your work to my email, hprado@teachps. If you send pictures of the work that you've done from there, I can collect them. So if you want to just send them there, that'd be easiest. Or you can upload them to Google Classroom. Either one works. But guys, let's get back to this last problem. So over here, we have 3 to the 22nd over 3 to the 5th. What is that equal to? Does that equal 3 to the negative 17th power or 3 to the positive 17th power? Notice your bigger base and exponent is in the numerator, and your smaller term is in the denominator. Right? So this one's actually 3 to the positive 17th. So this one does not work. 22 minus 5 is 17, so you get 3 to the 17th. Yeah, exactly. So that makes the next one incorrect also, right? They have 3 to the 17th. That's not the same. 3 to the 17th is, though. And if you look at the last one, 3 to the negative 22 plus 5, that one's also correct. Negative 22 plus 5 is 17. Negative 17. So all the ones that have checks on them are going to go into the equivalent box. All of the ones that have X's in them are going to go to the not equivalent box. I'll leave this up for a couple more seconds because we're about to move on to the next problem. Okay, so B, which of the following are equivalent to 2 to the negative 4 times 2 to the third, all raised to the third power? You guys, for this problem, can we simplify the inside of the parentheses? Can we simplify that? What's 2 to the negative 4 times 2 to the third? Can anyone write it using exactly, Miss Chong? Oh, well, actually, sorry, not quite. 2 to the negative 4 times 2 to the third. What's negative 4 plus 3? Let's look at this one more time. Let me rewrite this. Yeah, we're on number 2. So look, I rewrote the question for you guys, and they say that which of the following is equivalent to the following expression: 2 to the negative 4 times 2 to the third, all raised to the third power. So my question was, can we simplify what is inside of the parentheses before we think about the exponent? And my question was what is 2 to the negative 4 times 2 to the third? And then after that, I asked you guys what negative 4 plus 3 is. Why did I do that? Because we're using the product rule here, right? Negative 4 plus 3 is 1. So I can simplify what's inside the parentheses to 2 to the negative 1. Like so. Okay, now 2 to the negative 1 is inside of these parentheses. And when we use the power rule, we're going to actually say this is 2 to the negative third. Right? That equals 2 to the negative 3 power. We're using the power rule. Negative 1 times 3 is negative 3. So now we have 2 to the negative 3, which is the same thing as 1 over 2 to the third power. And 1 over 2 to the third power is a fraction. Right? That's a fraction that equals a certain number. And on the exit slip, that option is there. So if you guys are paying attention, you'll see that there's only one fraction that is the correct answer. 2 to the negative 3 is the same thing as 1 over 2 to the third power, which is 1 over 8. So that's one of the boxes that are equivalent, 1/8. There's also another answer on there that we have to notice by looking at the power rule again. So if we apply the power rule to this expression right away, we can rewrite this using multiplication. See, exactly, India. So it's 2 to the negative 12 times 2 to the 9th. Negative 4 times 3 is negative 12. 3 times 3 is 9. So that's our other option. Hope everyone saw that. Let's move on to the last question. Actually, question C, or 3. Oh, wow. I actually gave you guys 5 questions on this exit slip, so we're halfway there. Sorry about that. So which of the following expressions is equivalent to 10 to the negative 5th times 10 squared? See, Ms. Lopez? All righty. So 10 to the negative 5th times 10 squared. You guys, what's negative 5 plus 2? Ten to the negative 5 times 10 squared. 10 to the negative 3, exactly. So if you see that as an answer, make sure to check that. Remember, we can also look at 10 to the negative 3 as a fraction, which is 1 over 10 cubed, like so. And we know that 10 cubed simplifies even further because 10 times 10 times 10 is 1,000. So this is also the same thing as 1 over 1,000. I wouldn't say C is a valid option, India. That remember, everything inside of your parentheses is being raised to the third power, so that 1,000 is not going to work. Yeah, that one's not quite it. Yeah, D works. Right? D works. 1 over 10 to the third power is the same as 1 over 10 to the third power, like that, which is the same thing as 1 over 1,000. Let's look at question number 4. So which of these equations are correct? And there's 5 different options, or 6 different options. One second. Sorry, guys, I'm writing all these down. And last one. Whew, okay. So it's A, B, and D, or B, D, and E. Okay, A is not correct. or let's see, B, D, and E. D and E are correct. So options D and E are correct, India. That's a good job. Let's just go through all of them really quick. So the first one, you have 5 to the second power time all raised to the fourth power is 5 to the sixth. Sorry, 2. Can't read my own handwriting. So A is incorrect because the power rule tells us that we multiply those. So 2 times 4 is 8, not 6. That's why A is incorrect. B is tricky because we use the power rule again. We get 3 to the negative 10th, which is 1 over 3 to the 10th power. But, oops, dropped my whiteboard there. The difference is that their answer has a negative in the denominator. But when that value gets to the denominator, it should be positive. Right? It really should be 3 to the 10th. That's what it should be. So that's why it's incorrect. Let's look at C. So you have 4 to the negative 4th power, all raised to the second power. So C, when I use the power rule there, I do negative 4 times 2, and I get negative 8. That's correct. C is correct. So we'll put a big check on that one. You already told me D and E were answers, so that's correct, and we got 3. So that's what we got. One second. Let's look at question. Was that question 4? Okay, last question, number 5. All right, just got them down. Let's look at the last one, the last problem of this agenda. God bless. Ready? Okay, so we're going to check if all of these answers are equivalent. So 2 to the, what is that? 2 to the negative second power times 2 to the 8th. Well, if we look at that, we use a product rule. And we say that 2 to the negative second power times 2 to the 6th power, times 2 to the 8th power is 2 to the 6th power. So we get 2 to the 6th power. 2 to the 6th power is 2 times 2 is 4, times 2 is 8, 2 is 16, 2 is 32, and 2 is 64. If you guys put that in the calculator, you'll get 64. So A is correct. How about B? B is correct. You have negative 3 to the negative 5 times 3 to the first. So that's 3 to the negative 4. That's 1 over 3 to the fourth, which is 1 over 81. So B is correct. Good. And for C, 4 to the 4th power times 4 to the negative 3 is 4 to the 1st power. So that is just equal to 4. All right, guys, that one's pretty easy. So we just found out that the first 3 problems are correct. And by process of elimination, we can, skip the rest, but let's just solve them just in case. So 5 to the 3rd times 5 to the negative 1 is 5 squared, which is 25. 6 to the negative 8 times 6 to the 6th is 6 to the negative 2, so that's 1 over 36. 8 squared times 8 to the negative 4 is 8 to the negative 2, 1 over 64. Yeah, India. So A is correct, B is correct, and C is correct. D is incorrect, E is incorrect, F is incorrect. This is just practicing your knowledge of the product rule. All righty. I think that should conclude the lesson for today, unless anybody here has questions on old agendas. I can wait and go back if you want. Andy, I think you're the only one on here, so if you want me to go through old digital agendas, I can help you right now. And if not, then you can submit this and enjoy your weekend. Yes, we can. Let me get 1 second. I'm going to grab some water and I'm going to grab a little snack because I'm dying up here. Okay. Does anyone still need help? Sorry about that. Oh, all right. See you, India. Thank you for tuning in and participating. I really appreciate it. Let's see. So if anyone can get in the chat and let me know what they need help with, that would be awesome. If you want me to go over the first exit ticket, second exit ticket, first agenda, second agenda, let me know. Have a good weekend. Alrighty, let's see. Well, it looks like that is going to be it, folks. Tune in next time. I want to help you guys with any of the problems that you guys need. So please type something in the chat right now or forever hold your peace until next week. Alrighty, everybody have a great weekend. Take care. No problem, Susanna. Have a good weekend.